Tell me when it Stop. Hello, everybody. Welcome to Cloud Native. Today's DTT session will be about Cloud Native, an exciting topic, and not you can't really find it in many places. So, welcome all. I will briefly introduce myself. Some of you may have known me, and some of you may have not. So, I'm Zainab Kujur. I work at Huawei as a cloud expert. Today's agenda is we will start with the definition and history of cloud native. Then we will continue with cloud native pillars. Then we will proceed with cloud native services, the difference between cloud and cloud native, because they are different, and benefits of cloud native approaches, challenges in cloud native adoption, Huawei Cloud CCE and CCI, and future trends in cloud native. What will happen next? So, we will start with the definition, but first let's grasp cloud native technology. We know that it helps to, so I know that, I will briefly revisit the evolution of cloud computing. So initially, businesses used physical servers to store and process their data, which required substantial in-house IT management. So the shift to virtual machines allowed multiple virtual operating systems to run on a single physical server. Before virtual machines, we had to, run in one single physical server. But with virtualization technology, with hypervisors, we could create virtual machines, and that actually helped us save money. So making resource use more efficient and reducing the need for hardware. And as technology progressed, hypervisors enabled these VMs to share resources across multiple physical machines, which led to what we now recognize as cloud computing. This innovation allowed companies to access scalable computing power and storage as needed, laying the foundation for the development of cloud-native applications. So, what is cloud-native application? Cloud-native technology is a way of building and running applications that take full advantage of cloud computing. Instead of just moving traditional software to the cloud, cloud-native applications are designed specifically for the cloud. These applications are made up of small independent parts called microservices, which are packaged into containers. These containers can be easily moved, scaled, and managed across different cloud environments. So this means that companies can quickly update, change, grow their applications to meet customer needs. So in simple terms, cloud native is about creating software that is built to work best in the cloud, making it faster, more reliable, and easier to manage. So imagine you already have your application, but it wasn't built for cloud. If you move it to cloud, it will just be on the cloud, but still has that, like slow working way because it is monolithic. You have to redesign it for the cloud so that you can utilize what cloud offers for you. So let's look at the history of cloud native. In the beginning, software was built in large all-in-one pieces called monolithic applications. Everything in the application needed was tightly packed together in a single code base. These applications ran on physical servers that companies owned and managed themselves, which we call traditional IT. It required a lot of resources and effort to maintain, especially as the application grew. You had to maintain the infrastructure by yourself. You had to maintain the monolithic application. Like, it's very hard to scale. So let's look at the rise of virtual machines. In the early 2000s, virtual machines changed the game. Virtual machines allowed multiple operating systems to run on one physical server by creating separate, isolated environments on the same machine, which means that we could utilize a single physical machine better because it could be underutilized and you still, paid for it, you're still maintaining it. So with virtual machines, we get a better cost. This meant companies could use their hardware more efficiently, running more applications on fewer servers. Then there's the shift to cloud computing. Cloud computing took this idea further. Instead of buying and maintaining physical servers, companies could now rent computing power and storage from providers like Huawei. This made it easier to scale up or down based on demand, without needing to invest in lots of expensive hardware. So, as more companies moved their applications to the cloud, they realized that just moving old monolithic applications wasn't enough to fully benefit from the cloud. Developers started thinking about how to design software that worked better in the cloud, leading to the creation of cloud native principles. These ideas focused on making software that was easier to scale, more resilient, and quicker to adapt to changes, basically cloud native applications. And then there's introduction of containers and microservices. A big breakthrough was the introduction of containers, thanks to tools like Docker. Containers allowed us to package applications with everything they needed to run anywhere. This led to microservices, where we break down big applications into smaller independent services that are easier to manage and scale. So instead of building a monolithic application, we build microservices. And then, along with these technologies, companies started adopting DevOps practices to improve collaboration between development and operation teams. CI/CD pipelines became common, allowing teams to automatically test and deploy updates quickly and reliably. So, to support this growing trend, the Cloud Native Computing Foundation, as known as CNCF, was established. It promotes and supports cloud-native technologies, including important tools like Kubernetes, which helps automate the deployment and management of containerized applications. So, today, cloud-native technology is the standard for building modern applications. It helps companies move faster, scale more easily, and deliver better experiences to their customers, playing a crucial role in the digital transformation we see across the industries. So let's look at the cloud native pillars. We have four pillars: microservices, containers and orchestration, DevOps, and CI/CD, continuous integration and continuous deployment. So we know that one of the core pillars here, we see it, microservices. It involves breaking down an application into smaller independent services, as I have just talked about it. These microservices can easily be connected and communicate with each other via APIs. For instance, an e-commerce application might have distinct services for the shopping cart, payments, and inventory management. This modular approach allows teams to update or replace components without disrupting the entire system, which makes it easier to meet changing business requirements. Another fundamental pillar is the use of containers, which are lightweight, self-contained units that include everything needed to run an application in any environment. This build once, run anywhere approach simplifies development and deployments. Containers reduce conflicts between different programming languages and libraries because they can be deployed independently. As applications grow and the number of microservices increases, container orchestration becomes essential. Tools like Kubernetes help manage these containers, ensuring they run efficiently, automatically, and repair any issues and balance workload across the system. If we continue with DevOps, it is a critical pillar that supports cloud-native technology by fostering close collaboration between development and operations teams. In a cloud-native environment, DevOps practices focus on automating infrastructure and software delivery processes. This approach creates a culture where applications can be built, tested, and released more quickly and reliably, which helps organizations respond faster to customer needs and market changes. And if we continue with continuous integration and continuous delivery, it is the pillar that ensures cloud-native applications can be updated and deployed rapidly and safely. Automation through CI and CD pipelines allows for continuous testing and deployment of code changes, which reduces the risk associated with updates and enables frequent, reliable releases without the need for downtime or manual intervention. So let's look at these pillars one by one. I will first start with microservices. So here we see a monolithic architecture and microservice architecture. In monolithic architecture, the entire application is built as one big unit. All the parts, like the user interface, business logic, and data access, are tightly connected and work together as a single piece. This approach can be easier to start with, actually, but as the application grows, it becomes harder to manage. If you need to update or change something, you often have to redeploy the whole application, which can be slow and risky. Just imagine you make a new update and then you have to redeploy it. Scalability is a challenge here. If one part of the application needs more resources, you have to scale the entire application, which isn't very efficient. But if you look at the microservice architecture, it is a more modern approach and is a key part of cloud-native development. Instead of building one big application, you break it down into smaller independent pieces called microservices. Each microservice handles a specific function, like the user interface or data access, and can be developed, deployed, and scaled on its own. So you can scale each microservice on its own. This means if one service needs more power, you can scale just that part without touching the rest. You can just scale user interface without touching business logic and data access layer. Microservices communicate with each other through simple connections called APIs, allowing them to work together to form the complete application. Because they are separate, different teams can work on different services at the same time without causing problems for each other. So, from a cloud-native perspective, microservices are ideal because they fit perfectly with the goals of building scalable, flexible, and resilient applications in the cloud. Cloud-native applications are designed to take full advantage of the cloud. They can be spread across different cloud environments, scaled up or down depending on the demand, and updated frequently without needing to take the whole system down. This makes cloud-native applications more adaptable and better suited to the fast-changing needs of today's digital world. So in short, while monolithic architectures might still work in some cases, microservice architecture is much better for cloud-native development because it allows for greater flexibility, easier scaling, and better use of cloud resources. So I would like to sum up what cloud-native is for you. So basically, cloud native is taking full advantage. Cloud native application is just taking full advantage of what cloud offers to us. You design your application based on how it can work best on cloud and how it can use what cloud offers. So if we continue with the other pillar of cloud native, it's containers. What is a container? A container is a standard unit of software that packages up code and all its dependencies. It ensures that the application runs quickly and reliably across different computing environments. I'm sorry. Containers operate at the application layer. We see it. And multiple containers can run on the same machine. We see multiple containers here and they run in the same single machine. They share the same operating system kernel while they remain isolated from one another as separate processes. Even though they share the same kernel, they are remaining isolated from each other. Because containers are lightweight, typically only tens of megabytes in size, they take up much less space than virtual machines and operating systems. And if we compare to virtual machines are a way to abstract at physical hardware. So there's hypervisor, it supports the virtualization, it enables the virtualization. So multiple can run in a single physical machine thanks to hypervisor. Each virtual machine includes a full copy of an operating system along with the application. We see the operating system and the application. Necessary binaries and libraries, which often takes up to tens of gigabytes. So this can make VMs slower to boot and more resource intensive compared to containers. One minute, sorry. So if I continue with this, as our applications grow and you start using many containers, managing them actually becomes very challenging. This is where orchestration tools like Kubernetes comes into play. Imagine you have lots of containers and then you have to, like manage them by yourself. You need an orchestration tool. Kubernetes orchestrates the containers. The window. So Kubernetes helps manage these containers by automatically starting them, repairing any issues that arise, and ensures that they are efficiently distributed across your infrastructure. So think of Kubernetes as the conductor of an orchestra, ensuring that all parts of your system work together in harmony. So, what is orchestration and what problems I already told you that Kubernetes does this orchestration of containers, and I will respond to what problems does Kubernetes solve and what are the tasks of an orchestration tool. So I told you we have talked about containers and how they package everything an application needs into a small, efficient unit. But as you start using more containers, especially if you're running lots of different applications or microservices, keeping track of everything can quickly become overwhelming. That's where orchestration tools come into play. Orchestration tools like Kubernetes are designed to help manage all these containers automatically. Imagine you've got dozens or even hundreds of containers running across different servers. Without an orchestration tool, you would have to manage each by hand, starting them up, shutting them down, making sure they're working properly, and balancing the load so no single server gets overwhelmed. But thanks to Kubernetes, it does it all for you. It does all of that for you. It can automatically start up containers, repair them if something goes wrong, and make sure they are running efficiently across all your servers. It's like having a really smart manager who oversees everything, makes sure all the containers are working together smoothly and efficiently. And another thing Kubernetes does is help with scaling. Let's say your application suddenly gets a lot more users. Kubernetes can automatically create more containers to handle the extra load, and then scale them back down when things quiet down again. So this flexibility is one of the biggest advantages of using orchestration tools in a cloud-native environment. So if I sum it up, in short, while containers make it easy to package and run applications, orchestration tools like Kubernetes are what make it possible to manage and scale those applications efficiently as they grow. Let's continue with the third pillar of cloud native, which is DevOps. So DevOps, if we talk about the name, it is a combination of development and operations. We see how Wikipedia defined it. So DevOps is a software engineering culture. DevOps is a culture and practice that aims at unifying software development and software operation. DevOps aims at shorter development life cycles, increased deployment frequency, more dependable releases, in close alignment with business objectives. So DevOps is a really important part of cloud native technology because it brings together traditionally separate teams. I'm sorry. Which is development and operations. In the past, developers would create the software and then they would hand it off to the operations team to deploy and maintain it. But this separation often led to delays and misunderstandings. I'm sorry, if you give me a second. I'm a bit sick, so I'm sorry for my voice. So I was talking about DevOps. It changes the culture. It changes the culture by creating a culture of collaboration where developers and operations work closely together from start to finish. So before they would work separately, but with DevOps, we combine development teams and operations teams together. So this close cooperation helps ensure that the software is built, tested, and deployed quickly and reliably. What was Cloud Native all about? It was about being fast to deploy. So DevOps is a culture and a set of practices that aim to unify software development and operations. By doing this, DevOps aims to shorten development life cycles, increase the frequency of deployments, and produce more dependable releases. All of this is done with the goal of aligning closely with business objectives. So in summary, DevOps isn't just about tools and processes, it's about fostering a culture of collaboration between developers and operations teams, which in turn leads to more efficient and reliable software development and deployment. So let's continue with the fourth pillar of Cloud Native, which is CI and CD, continuous integration and continuous delivery. In a cloud native environment, continuous integration, it plays a crucial role. Traditionally, developers would work on their code separately and merge everything together at the end, just at the end, which could lead to conflicts and delays. With continuous integration, however, developers frequently merge their changes into a shared repository multiple times a day, which is a better practice. Each time code is merged, automated tests are run to catch any issues early on. This practice helps ensure that code base is always in a working state, ready for deployment. So CI is typically done with the help of a CI server. Whenever a developer commits a code change, the continuous integration server automatically triggers a build and runs tests to make sure nothing is broken. If a problem is found, the developers are immediately notified, allowing them to fix issues as they arise, rather than discovering them later. Imagine if they only submitted it at the end. This constant merging and testing make the development processes much smoother and faster, which is essential in a cloud-native environment where rapid innovation and reliable releases are key. And if we continue with continuous delivery is another crucial part. In a cloud-native environment, the goal is to have the code that can be deployed to production at any time. So even if the decision to deploy isn't made, the code is still in a state where it could be deployed if needed. So it should be in a state where it should be, deployed right away. It should be in that state. This practice is crucial because it allows for more frequent releases and quicker responses to customer needs or market changes. Excuse me. And the beauty of CI/CD in a cloud-native environment is that it enables teams to move quickly and confidently. Automated tests and deployment pipelines ensure that code changes are safe to deploy, reducing the risk of errors and making rollbacks easier if something goes wrong because you're frequently submitting your code. This approach also aligns perfectly with the microservices architecture often used in cloud-native applications, where small independent services can be updated and deployed without affecting the entire system. So in summary, CI and CD are fundamental practices in cloud native development, helps teams to continuously improve their applications, respond quickly to changes, and deliver value to customers faster and more reliably. I'm sorry, excuse me. So let's continue with cloud native services. Let's talk about them and why they are so essential in today's digital landscape. Uh, so cloud native services and technologies are the backbone of building, running, and deploying scalable applications across any environment. They are key for building, running, and deploying. While end users and business customers interact with the application itself, these services operate behind the scenes to ensure everything runs smoothly. For instance, when we talk about cloud native services, we're referring to several key components. First, we have a service. We have the as a service offerings from cloud providers, and they include infrastructure as a service, platform as a service, and software as a service. These models give you the flexibility to scale your resources on demand, meaning you only pay for what you need when you need it. Next, we have microservices. These are the small independent services that together make up your application. Microservices offer incredible flexibility because they allow you to update or scale specific parts of your application without disrupting the entire system. We talked about this when I was comparing microservices to monolithic applications. And finally, there are APIs, application programming interfaces. You should think of APIs as the glue that connects these microservices and other services, ensuring smooth communication and data flow between them. Without APIs, your microservices wouldn't be able to work together effectively. So, why are these cloud native services so important? They ensure that your application can adapt to changing demands, maintain high availability, and provide a seamless experience for your users. So, by leveraging these services, you can focus on what really matters, delivering value to your customers, while the underlying infrastructure takes care of scalability, performance, and reliability. So, in today's fast paced digital environment, cloud native services are the foundation that enables modern applications to thrive. They ensure your software can meet both current and future demands with ease. And what is the difference between cloud and cloud native? I think you might have understood till now, but let's proceed with it. We are really looking at two different approaches to how applications are designed, built, and deployed in relation to cloud environments. Let's start with cloud. Cloud computing is all about delivering computing resources like servers, storage, and databases over the internet. This is a shared pool of resources, and we deliver it to you as cloud providers. This allows businesses to access and scale their resources whenever they need them. When we mention the cloud, we are usually referring to services provided by companies like Huawei Cloud. And businesses often move their existing applications to the cloud to take advantage of these flexible on-demand resources. However, many of these applications were originally designed for on-premise environments. And even though they can be hosted in the cloud, they might still follow older monolithic architectures. These traditional applications may need significant modifications to fully leverage what the cloud has to offer. And this is where cloud native comes in. Cloud native isn't just about using the cloud, it's about designing and building applications specifically for cloud environments. These applications are created from the ground up to take full advantage of cloud computing their benefits like scalability, flexibility, and resilience. Cloud native applications are typically built using modern practices like microservices. I talked about the cloud native pillars like microservices, containers, and DevOps, which allow them to run in dynamic, distributed environments. This makes them incredibly adaptable, able to scale and evolve quickly to meet changing demands. Unlike traditional applications, cloud native ones are composed of small independent services that can be updated, deployed, and scaled individually, making them perfect for continuous development and deployment. So, if I sum it up, cloud is about where you run your applications using the internet to access scalable resources. And on the other hand, cloud native is about how you build and run those applications, designing them to fully take advantage of the cloud's capabilities right from the start. So, cloud native isn't just about moving your applications to the cloud, it's about rethinking how you develop software to truly maximize the benefits that cloud computing can offer. So, let's have the first round of our questions, Kahoot, my favorite part. 1 minute. I will open it 1 second. So let's start. Here is the pin and the QR code. Game 164 380 164. You can scan the QR code or you can join on your browser by game pin. I think this week's DTT topic is very important because the future is literally about cloud native. We are already in the cloud, we are a cloud provider, and you can have better apps by following the cloud native best practices. So, future is about cloud native, and you are welcome in this session. I will wait 2 more minutes. I will start at 35. So while we're talking about it, let's talk about CNCF. The Cloud Native Foundation, they hold conferences every year actually to talk about the cloud native applications and where it's going. And I think they're very beneficial. And if you're, interested about these things, I would recommend you to search about it. I'll be right back. All right, I'm back. Thank you for waiting. There's only 8, 9. Okay, joined. I will wait 1 more minute. I'm actually excited for this week's Kahoot and this week's topic. So, excuse my voice. I'm sorry for it. Number is 8 again. There was one person that maybe accidentally went out. All right. Maybe I should just start it now. Burak, welcome. All right, let's start. Cloud native apps are built as monolithic systems, requiring full redeployment for updates. Is it true or false? Congratulations. Let's proceed. What is the primary benefit of using microservices in cloud native architectures? All right, congratulations to those 5 people. But let's see who won. We will have a second round. So in the third place, there is Hellos. In the second place, there is Sheriff Amr. And in the first place, who is it? Abdul Rahman. Congratulations. Please contact on our WhatsApp group to get your gift. All right. I will proceed with our presentation. Let's see the benefits of cloud native approaches. So, one of the biggest advantages of cloud native technology that it drives faster innovation. We talked about what it does. It is, just making things faster because it is utilizing what cloud has to offer. Because cloud native architectures use smaller, loosely coupled services. What? Oh, sorry. I'm sorry. I didn't share my screen. All right, now you see my screen. So I was saying, 1 minute. I was saying that the biggest advantage is faster innovation because cloud native architectures use smaller, loosely coupled services. So teams can work independently and develop autonomously. They can work, at the same time concurrently. This setup boosts developer productivity and velocity, makes it easier for developers to try out new ideas and bring innovations to life quickly. Another key benefit is reliable releases. With cloud-native architectures, developers can rapidly build, test, and deploy both new and existing services. This not only speeds up the time it takes to bring products and services to market, but it also reduces the risk associated with deployments. And then there's like scalability, lower costs, higher availability, portability, better security, and improved compliance. So, what are the challenges in cloud native adoption? I was talking about everything nicely, but there are challenges. So, it offers lots of benefits, but we should also recognize the challenges, the trade-offs. Implementing cloud native computing isn't always straightforward. Beyond just adopting new tools and technologies, it requires significant cultural shifts within an organization to be truly successful. There are some common challenges that many organizations face when going cloud native. For one, dealing with distributing systems. And the many moving parts involved can be very overwhelming, especially if you don't have the right tools or processes in place to manage development, testing, and deployment. And additionally, without proper cost optimization and oversight, operational and technology costs can increase significantly in a cloud environment. So, another challenge is the lack of existing skills. You might not be able to find the right person to work with and integrate a more complex technology stack. This can be a major barrier for teams that are used to more traditional approaches. There is also the issue of cultural resistance. Shifting to cloud native technologies and embracing DevOps best practices requires a change in mindset, and not everyone in the organization may be on board with that. On top of all this, communicating the value and concepts of cloud native to non-technical executives can be very difficult, which can make it hard to gain the necessary support and buy-in for those initiatives. However, none of these challenges are unmanageable if you have the right expertise and strategy. For instance, starting with a simple lift and shift approach, where you move existing applications to the cloud as they are, can be a good way to begin. But it's important to understand that this approach won't deliver many of the real benefits of cloud native unless you are prepared to go further and re-architect your applications, because you have to design it for cloud native. That's why we recommend I recommend not treating cloud native adoption as a one-time multi-year project. Instead, it should be seen as an ongoing journey, because it is one where you constantly iterate, learn, and improve as you go. Technology never stops. We should always iterate and learn as we go. So this approach allows you to gradually build the capabilities and culture needed to fully leverage the power of cloud native technology. We talked about common challenges there: managing distributed systems, increased costs, and the skill gaps, finding the right person, and cultural resistance and communication barriers with the non-technical person. So, Huawei has products that are for cloud native. So we have our Cloud Container Engine. It is a fully managed service that makes it easier to deploy, manage, and scale applications that run in containers. It is built on top of Kubernetes, which is I talked about it. This is the main platform used worldwide to manage the containers. This is the orchestration tool for containers. So how does CCE and Kubernetes work together? CCE takes everything that Kubernetes does and adds more features to make it simpler and more efficient. Normally, setting up and managing Kubernetes on your own can be very complicated, but CCE, what it does is it automates a lot of that work. And it is certified by CNCF, the Cloud Native Computing Foundation, which means it works perfectly with Kubernetes and stays up to date with all its latest features. So if you're already familiar with Kubernetes, you'll find that CCE goes a step further by handling many of the repetitive and time-consuming tasks involved in managing those containerized applications. So with CCE, you can easily create Kubernetes clusters through Huawei's web console with just a few clicks. This way, you don't need to worry about setting up the infrastructure yourself. Once your clusters are running, our CCE takes care of deploying your applications and scaling them up or down depending on your needs. And one of the key benefits of using the CCE is its high performance and scalability. Whether you're running regular applications or more demanding tasks, like those requiring the GPU power for AI, our CCE, Cloud Container Engine, can manage it. Plus, it's built on Huawei's high-speed infrastructure, so it can quickly adjust to meet whatever your demands are. So if I cut it in short, our Huawei Cloud CCE makes it much easier to use Kubernetes with added tools and automation that help you build and manage cloud-native applications more effectively. So if we look at the concepts of basically just Kubernetes and CCE. We see what a cluster is: pod, node, service, container, and image. So a cluster is a collection of cloud resources required for running containers, such as cloud servers and load balancers. And a pod consists of one or more related containers. They share the same storage and network space. And what is a node? A node is a server on which containerized applications can run. And a service is an abstraction which defines a logical set of pods and a policy by which to access them. And a container is a running instance of a Docker image. Multiple containers can run on the same node. And if we talk about the image, it is a binary that includes all of the requirements for running a container. So a container is basically the runtime of an image. And let's look at the scenario here. So I told you that CCE automatically adjusts the compute resources in your Kubernetes cluster based on the service load. So this means that when your application experiences a spike in usage, CCE can automatically add more cloud servers or nodes to handle the increased demand. Conversely, when the load decreases, CCE can reduce the number of servers, ensuring that you're only using and paying for the resources you need. And if we look at the benefits, it is flexible. CCE supports multiple scaling policies, allows containers to be added or removed very quickly. And then CCE continuously monitors the health of your pods. So we ensure that you have high availability, and then it's cost, basically after doing all of these, we provide you low cost. Since CCE scales resources based on the actual usage, you're only billed for the cloud servers you use, helping you to optimize costs by avoiding over provisioning of resources. So in this scenario, we see users and an elastic load balancer and then a Kubernetes cluster. So let's look at what Huawei Cloud container instance is. It is a serverless container engine. It allows you to run containers without creating or managing any cluster. So traditionally, to run containers workloads using Kubernetes, you need to create a Kubernetes server cluster first. And in this serverless model, a cloud provider runs servers dynamically, allocates resources so that you can build and run applications without having to worry about server statuses. So this model helps you improve development efficiency and reduce IT costs. Our CCE Cloud Container Instance uses the serverless model that allows you to directly create and use containerized workloads on the console or by calling kubectl or Kubernetes APIs. And you only pay for the resources consumed by these workloads. So in summary, Huawei Cloud Container Instance is designed to make deploying and managing containerized applications as easy and cost-effective as possible. So let's talk about what future holds for cloud native, the future trends. We know that cloud computing is evolving towards edge computing, where data is processing closer to where data is generated. So instead of relying solely on distant data centers, this approach is crucial for companies with strict needs for low latency. So if they need low latency, the edge computing is for them. So high security or limited bandwidth that centralized cloud system can't always meet. Edge computing is gaining traction as large cloud providers set up smaller local data centers, and some companies even build their own edge systems because they want low latency. For example, manufacturers might need to process data from thousands of devices on a factory floor in real time and send that data to tablets used by employees. By using edge computing, they can handle this data locally with minimal delay without overwhelming their central cloud infrastructure. So at the core of this shift, technologies like Kubernetes enable the flexible deployment of applications across different environments, whether on premises, at the edge, or in the cloud. They ensure they run smoothly with low latency. This allows businesses to maintain high performance computing without needing to invest heavily in physical infrastructure. So, in summary, edge computing represents the future of cloud technology, bringing powerful computing capabilities closer to the user and allowing companies to operate in a wider range of environments with greater efficiency. I hope you enjoyed today's DTT. I will proceed with the second round of Kahoot questions. And then we will finish. I will wait a few more minutes for more people to join. All right, I will start this round of Kahoot questions. CI in cloud native environments involves developers merging their code changes only at the end of the development cycle. Is it true or false? False. Congratulations to the correct answers. The scoreboard. Let's proceed with the second question. Which of the following best describes continuous delivery in cloud native environments? All right, congratulations. Let's see the winners. The most exciting part. Ahmed Halali, third place, congratulations. Mustafa Tariq, second place, congratulations. And the first place is Yunus Ozan, congratulations. All right. So thank you all for joining me today. We talked about cloud native, what it is, and the difference between cloud and cloud native and the pillars of cloud native. I hope you all have learned about cloud native. It is new and not many people know about it. So I hope I could add valuable insights for you, valuable information to you. And you can, if you are not following us on these platforms, this is our QR code for Instagram and on Facebook, and this is our WhatsApp group chat. You can reach us on here, especially the winners. Please reach us on our WhatsApp group, and then we will deliver your surprise gifts to you. So if you have any questions, please write them down, and see you next time, next week. Thank you for your well wishes, Nejate. All right, so if you don't have any questions, I will end this session. See you next week.